These are our 9.3 notes. The definition of an ellipse is the set of all points for which the sum of the distances from two fixed points, called the foci, is constant. And in order to understand that definition, let's talk about our ellipses. There's two major kinds. One is a horizontal major axis and the other is a vertical major axis. Where the major axis in a horizontal major axis ellipse is the x-axis and the minor axis is the y-axis. And over on the vertical major axis ellipse, the major axis is the y-axis and the minor axis is the x-axis. And this makes sense because if you have a wider ellipse, the x-axis has the bigger distance, so it's your major axis. And if you have a vertical major axis ellipse, it is a taller ellipse, and so the major axis is then going to be your y-axis. What you need to know is that each of these ellipses have foci on them. Foci is plural for focus. And the foci always fall on the major axes. And so they look like the two dots in each of these ellipses. And you don't have to draw this on your paper, but what happens is if I pick any point on the ellipse and I find the distance to each of these foci, and I add those two distances together, the sum should be the same as if I picked any other point on the ellipse and found the two distances as well and added them together. And all of these sums are constant all the way around the ellipse. And like I said, you won't need to have to draw that on your paper, but that's what the definition of an ellipse is and what it means. What you need to know are some important characteristics of each of these ellipses. And the equation for a horizontal major axis ellipse is very similar to a circle. The equation is x minus h squared all over a squared plus y minus k squared all over b squared equals 1. And a vertical major axis ellipse is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. And the only difference between those two equations is where your a squared and your b squared is. And if you know that in an ellipse, and only in an ellipse, a is greater than b, you will be able to determine what the major axis is because the bigger number is always under the variable of the major axis. So for example, in your horizontal major axis ellipse, a squared is underneath x, so your major axis is the x-axis. Over on the vertical major axis ellipse, a squared is underneath y, so the y-axis is your major axis. On either of them, the center is going to be h comma k, which you should be able to relate to a parabola, a circle, point slope formula. And you're going to have to find all these major parts down below. And the first one that's probably the easiest to find are the radii, because I can go to my x variable and look at the number underneath it and take the square root. And when I square root a squared, I get a. And I put a plus or minus in front because from my center I'm going to go right a spaces and left a spaces. And I can do the same thing for the y radius. I go to the y variable, the number underneath it is b squared, and I square root it. And I get plus or minus because from the center I'm going to go up b spaces and down b spaces. Same idea over on the vertical major axis ellipse. I go to x, and the number underneath it is my b squared, so I get plus or minus b. And under y, I have a squared, so I get plus or minus a. And that means I'm going to go to the left and the right b spaces and up and down a spaces. When I ask you for the major and minor axes, I'm looking for the distance from one end to the other. So in my horizontal major axis ellipse, if I'm going left and right a spaces, I can double it, and that gives me my entire distance. If I'm going up and down b spaces, I can double b, and that gives me my entire distance from the top to the bottom of the ellipse. Same idea, and actually these two are exactly the same over in the vertical major ellipse and with the major and the minor axes. They do not switch because again, a is always bigger than b. So my major axis is going to come from doubling a and my minor axis is going to come from doubling b. Your vertices, when determining your vertices and co-vertices, your vertices are always going to be on the major axes. So on your horizontal major axes ellipse, they're over on the left and right. On the vertical major axes ellipse, they're at the top and bottom. And your co-vertices will always be on the minor axes. So on the horizontal major ellipse, the co-vertices are at the top and the bottom. And on the vertical major axes ellipse, the co-vertices are on the left and the right. And so what that means is that if they're on the left and the right, the x-coordinate is going to be changing from the center. If they're on the top and the bottom, the y-coordinate is going to be changing from the center. So in my horizontal major axes ellipse, I'm going to go to the center, which starts at A, and my vertices are on the left and the right. So I'm going to take the x-coordinate and I'm going to add or subtract the x radius, and the y-coordinate will not be affected. In the co-vertices, the x-coordinate is not affected, but I take the y-coordinate, which is k, and I add or subtract the y radius. Over on the vertical major axes ellipse, your vertices are at the top and the bottom, so my x-coordinate is not affected. I take the y-coordinate and I add or subtract the y radius. In the co-vertices, they're on the left and the right, so I take the x-coordinate, add or subtract the x radius, and the y-coordinate is not affected. Finally, to find your foci, you're going to need the formula a squared minus b squared equals c squared. Kind of like the Pythagorean theorem, but with a minus instead of a plus. A is always the bigger number. Subtract b, the smaller number. You'll get your c squared. And when you take the square root of that number, that's the distance for your foci. So foci are always going to be on the major axes. So like my vertices on the horizontal major axes ellipse, the x-coordinate is going to change. I'm going to take the x-coordinate and add or subtract c. The y-coordinate will not change. Over on the vertical major axes, look at your vertices. The x-coordinate does not change. The y-coordinate does, and I'm going to add or subtract c. And that's a lot of formulas for you to memorize. What might make more sense is when we start doing all of the problems, but at least you have somewhere to reference in case you get confused. So let's start writing equations of ellipses, and what I do first is I always write the setup, and the setup is two fractions added together and they have to equal 1. In this case, my center is at 0, 0. So I can right away just go ahead and write x squared and y squared on the top of my two fractions. If I count the x radius, 1, 2, 3, 4, 5, I square 5 and I put 25 underneath. I count my y radius, 5, 6, 7, 8. I square it and I put 64 underneath and I'm done. Moving on to number 2, two fractions added equal to 1. The center is still at 0, 0. X squared and y squared go on the top. My x radius is 6, so I square it and write 36. My y radius is 2, so I square it and put 4. Number 3, I set up my fractions equal to 1 added together. The center is at 0, 3 this time. So x squared is going to stay like it was before, but the y is going to become y minus 3 squared. The x radius is 5, so I square it and write 25 underneath x. And the y radius, 2, 3, 4, 5, 6, is 6, so square it and put 36 underneath. On number 4, I'm going to set up my fractions equal to 1. I find the center at negative 3, 4. So on top of my fractions, I write x plus 3 squared and y minus 4 squared. I count my radius. My x radius is 6, so I write 36. My y radius is 4, so I square it and write 16. On number 5, I'm going to have to find the center. So what I do is I locate the left and the right, and the top and the bottom, your co-vertices and vertices. vertices on the top and bottom, co-vertices on the sides. And your center is where all four of those intersect. So my center on this one is at -3, -2. I set up my fractions. The center is x plus 3 squared and y plus 2 squared. My x radius is 6, so I square it and write 36. My y radius is 7, so I square it and write 49. And I can do the same thing over on the last one, number 6. I find my vertices on the left and the right, co-vertices at the top and the bottom. The center is right in the middle. So my center is at 3, -3. Set up my fractions, equal to 1. X minus 3 squared, y plus 3 squared. I count the x radius, it's 5, so I square it and write 25. The y radius is 1, so instead of squaring and writing 1 in the denominator, anything divided by 1 is just itself. So I'm going to leave this as y plus 3 squared, no fraction, or nothing in the denominator. Okay. When you have to graph them yourself, you have to determine the 8 things, and on quizzes or tests, I'm not going to tell you what the 8 things are, so we are going to practice with this. The first one is the center, it's at 0, 0. I'm going to find the major axes. I abbreviate that with a capital M, which means I go to the bigger number and I square root it. 16 square root is 4, and I double it. So I'm counting a total of 8 spaces from the top to the bottom of the ellipse. My minor axes, lowercase m. I go to the smaller number, which is 9, square root it. My radius is 3, and double it, I get 6. And we actually just talked about the x radius and the y radius as well. The x radius is the square root of the number underneath x, so plus or minus 3. The y radius is the square root of the number underneath y, so plus or minus 4. I have to find my vertices, my co-vertices, and my foci. Okay. So my vertices are going to come from the bigger number, and it's underneath y. So that means from my center, x is going to stay the same. I'm going to count up 4 spaces and down 4 spaces from the center. My co-vertices, I go to the smaller number, it's underneath x. So from the center, I'm going to count to the right 3 spaces and to the left 3 spaces. And it's really easy when the center is 0, 0, because the x-coordinate or the y-coordinate are just going to change to the radius. For my foci, I have to take the bigger number and subtract the smaller number. 16 minus 9 is 7. That's your c squared. So in order to get c, I take the square root. And the foci are always on the major axes, which in this case, the bigger number was underneath y. So I'm going to go to 0 square root of 7 and 0 negative square root of 7. When I plot this, my center is at 0, 0. My x radius was right 3, left 3. My y radius was up 4 and down 4, and you can check that all of these coordinates match what you have over on this side of your paper. And I draw in my ellipse. And the last thing that I have to do are also place my foci, and I know that the square root of 7 is in between the square root of 9 and the square root of 4. And the square root of 4 is 2, and the square root of 9 is 3. And 7 is a little bit closer to 9 than it is to 4, so I'm going to count a little bit closer to 3 spaces when placing my foci on the major axes. So let's try another one. Always make sure you reduce your fractions. 2/8 reduces to 1/4, and 2/50 reduces to 1/25. So my center in this case is at 0, 0. My major axes I go to the bigger number and square root it. I get 5 and I double it. My minor axes, I go to the smaller number and square root it. I get 2 and double it. The x radius is the square root of the number underneath x, so plus or minus 2. The y radius is the square root of the number underneath y, so plus or minus 5. My vertices in this case, the y coordinate is going to change because the bigger number is underneath y. So I'm going to go to 0, 5, and 0, negative 5. My co-vertices, the x coordinate is going to change because the smaller number is underneath x. I'm going to go to 2, 0, and negative 2, 0. My foci, I'm going to take the bigger number, which is 25, and subtract the smaller number, which is 4. It gives me 21. That's my c squared, so I square root it. My foci go along with the vertices and the major axes, which is the y-axis. So I'm going to go to 0, square root of 21, and 0, negative square root of 21. If I plot this, the center's at 0, 0. My x radius was 2, right and left. My y radius is 5, right and left. And you can check all of the vertice and co-vertice coordinates. They should match. Draw your ellipse in. And then go back and place your foci. And the square root of 21 is in between the square root of 25 and the square root of 16. So it's in between 4 and 5. A little bit closer to 5. So I'm going to count 1, 2, 3, 4, and make it just a little bit closer to 5. And sometimes you just have to estimate. On the last one, we have to have all of these equations or inequalities equal to 1. And so in order to do that, I'm going to divide by 36. And so I end up with x squared over 9 plus y squared over 4 is greater than 1. And while I'm thinking about these greater than symbols, we do need to go back and alter this one. Instead of an equal to symbol, it will not get an equal to because it's dashed, and since it's shaded inside, it's a less than. So comparing that to this one, the center of this one is still at 0, 0. The major axes, I go to the bigger number, which is 9, square root it and get 3, double it and get 6. Minor axes, smaller number is 4, square root is 2, double it, I get 4. The x radius, again, square root of the number underneath x is plus or minus 3. The y radius, square root of the number underneath y is plus or minus 2. Vertices come from the bigger number, so from the center, I'm going to go to the left and to the right 3 spaces, so 3, 0, and negative 3, 0. Co-vertices come from the smaller number. The y radius is the smaller one, so 0, 2, 0, negative 2. Foci is bigger number minus smaller number, a squared minus b squared. I get 5. And I square root both of those to figure out c. So my foci are at square root of 5 comma 0 and negative square root of 5 comma 0. I plot 0, 0. I go to the right 3 spaces, left 3 spaces, up 2, down 2, and I verify that those coordinates match the coordinates that I have for my vertices and co-vertices. And I go to draw my ellipse in, but then I realize that there wasn't an equal to symbol. So I'm going to go back and make it dashed. I have to place my foci, and the square root of 5 is between the square root of 4 and the square root of 9, and a little bit closer to 4 than 9. So I'm going to go a little bit past 2 spaces. And I'm going to shade the outside because it has a greater than symbol. And let's do a few where the center is not at 0, 0. So in this case, my center is at negative 4, 6. My major axes, bigger number, is 36, square root of 6, double it, you get 12. My minor axes, square root 25, you get 5, double it is 10. The x radius is plus or minus 6. The y radius is plus or minus 5. And here's where you're going to have to think a little bit more. Your vertices and covertices are now not centered around 0, 0. So the bigger numbers underneath x, that means in my vertices, the x coordinate is going to be changing. So if I'm going from negative 4 and I'm going to the left or the right 6 spaces, I have to add or subtract 6. Negative 4 plus 6 is 2, and negative 4 minus 6 is negative 10. The y coordinate does not change. In my covertices, the x coordinate doesn't change. I'm starting at 6 and I'm going up or down 5 spaces. 6 plus 5 is 11. 6 minus 5 is 1. My foci are always the bigger number minus the smaller number. In the denominators, you get 11. That's c squared, so square root both of them. So for my foci, I'm going to start at negative 4, and I'm going to add or subtract the square root of 11, comma 6. And I will let you condense them like that for just the foci when you have a square root and the number does not come out to be an integer. When I'm drawing in my axes, I'm going to keep in mind that my center is at negative 4, so I'm going to move my y-axis over, comma 6. So I'm going to move my x-axis down so that I can plot negative 4, 6 somewhere near the center. It doesn't have to be exactly, but somewhat close, so that I can go to the right and the left 6 spaces, and I can go up or down 5 spaces. And I have enough room to do that. This one is a dashed ellipse because it doesn't have an equal to symbol. It's going to get shaded inside because it's less than. And my vertices are at negative 4 plus the square root of 11, and you can type that into your calculator. And negative 4 minus the square root of 11. When you do that, you should get negative 0.68 and negative 7.32, which obviously you're not going to be able to get that exact. But if I go negative 0.68, right about here, and negative 1, 2, 3, 4, 5, 6, 7.32, right about here. And if you did it right, they should look equidistant from the center and from your vertices, and they do. On the next one, it cannot equal 25, it has to equal 1. So I'm going to divide everything by 25. 5 over 25 reduces to 1/5, so that's where the y squared over 5 comes from. Your center is at 2, 0. Your major axes, square root of 25 is 5. Double it, you get 10. Minor axes, the square root of 5 is not an integer, so I'm going to leave it as the square root of 5 and double it. The x radius is plus or minus 5. The y radius is plus or minus the square root of 5. Your vertices, the x coordinate is going to change because that's where the bigger number is. 2 plus 5 is 7. 2 minus 5 is negative 3. In your covertices, the y coordinate is going to change. 0 plus the square root of 5 is the square root of 5. And 0 minus the square root of 5 is negative root 5. For your foci, you take the bigger number and subtract the smaller number. And when you get 20, you can simplify the square root of 20. It becomes 2 root 5. So on my foci, I'm going to go to 2, and I'm going to add or subtract 2 root 5, and the y coordinate is going to stay the same. If I plot 2, 0, I'm going to move my y-axis over to the left. My x-axis will stay. Here's 2, 0. I go right or left 5 spaces. and I go up or down the square root of 5, which again, the square root of 5 is between the square root of 4 and the square root of 9. So it's a little bit more than 2. There it is. Drawing my ellipse. My foci are at 2 plus or minus the square root of 5, which if you type those into your calculator should give you the decimals 6.47 and negative 2.47. So I count from the center, 1, 2, 3, 4, 5, 6.47 and negative 2.47. They look pretty equidistant. Okay, last one. When I divide everything by 100, 4 over 100 becomes 1/25. 25 over 100 reduces to 1/4. So my center is at 7, negative 1. My major axes, the square root of 25 is 5, doubled is 10. Minor axes, the square root of 4 is 2, doubled is 4. The x radius is plus or minus 5. The y radius is plus or minus 2. My vertices, the bigger number is underneath x, so the x coordinate is going to change. 7 plus 5 is 12. 7 minus 5 is 2. In the covertices, the y coordinate is going to change, so negative 1 plus 2 is 1. Negative 1 minus 2 is negative 3. For the foci, I take 25 and I subtract 4, gives me 21. Square root. So for the foci, I'm going to start at 7 and I'm going to go right or left the square root of 21. My y coordinate doesn't change. If I have to plot 7, negative 1, I'm going to put my y-axis over to the left and my x-axis up just a little bit. Here's my center. I go right or left 5 spaces, up or down 2, and hopefully those match your vertices and covertices. I draw in my ellipse. Seven plus the square root of 21 is 11.28. I'm sorry, 0.58. And 7 minus the square root of 21 is 2.42. So I count to 8, 9, 10, 11.58 and 12.42. And there's my ellipse. Okay, making sure you can also change to general form. I'm going to take 25 out of my x's, so I have x squared minus 4x, and leave a space. I'm going to take 9 out of my y's, y squared plus 2y, leave a space. And I'm going to move 184 over to the other side by subtracting it. Give myself some more space. I complete the square, and I get 4. And over here I get 1. But then I have to multiply the 4 by the 25 out in front, so I actually add 100. And the 1 by the 9 out in front, so I add 9. The 25 stays out in front, I get x minus 2 squared. 9's out in front, I get y plus 1 squared. Negative 184 plus 100 plus 9 gives me 225. And I have to make my equation equal to 1, so I divide by 225. So I end up with x minus 4 squared over 9 plus y plus 1 squared over 25 equal to 1. And you can find all important information. Number 14, I factor 16 out of my x's, so I get x squared minus 4x. I factor 25 out of my y's. There's only a y squared. I bring 336 over to the other side. I complete the square and add 4. and make sure I multiply it by the 16 out in front, so I actually write 64 on the other side. And the y squared, you don't need to complete the square because there's no linear term. So I end up with 16x minus 2 squared plus 25y squared. And I end up with 400 on the other side. When I divide everything by 400, I end up with minus 2 squared all over 25 plus y squared over 16 is equal to 1. And there's your general form. Working backwards, make sure you can also get rid of fractions. I'm going to have to multiply by the least common multiple of 9 and 49, and that is 441. So when I distribute 441 divided by 9, gives me 49. Distribute again. 441 divided by 49 is 9. On the other side, I get 441. FOIL first. So 49 times x squared minus 4x plus 4 plus 9 times y squared minus 6y plus 9 equals 441. Distribute 49x squared minus 196x plus 196 plus 9y squared minus 54y plus 81 equals 441. And then make sure you write your terms in the correct order. And we write alphabetical and decreasing exponents. So 49x squared plus 9y squared minus 196x minus 54y. 196 gets added to 81, and then to move the 441 over to the other side, you subtract it. And so altogether, you should get negative 164, and it's equal to 0. And the last thing that you should know is that sometimes you will end up with fractions in the denominator. So I'm going to take the denominator and just bring it up to the top, because when you're dividing by a fraction, it's like multiplying by the reciprocal, and then you can just get rid of them. Don't be intimidated. In this case, I have to multiply by the least common multiple of 4 and 1, which is 4. When I distribute here, the 4's cancel out, so I have 9x minus 4 squared. When I distribute here, nothing cancels out, so 9 times 4 is 36, y plus 3 squared. On the other side, you get 4. FOIL, x squared minus 4x, minus 8x plus 16. On the other side, y squared plus 6y plus 9. Distribute 9x squared minus 72x plus 144 plus 36y squared plus 216y plus 324 is equal to 4. And then reorder everything. So 9x squared plus 36y squared minus 72x plus 216y, 144 plus 324, and subtract 4. I believe is 464. It is. And so these are your notes on ellipses. There are a lot, and you will have a second day to practice on them. Please go back and use your formulas and use your notes if you need help with them. Okay, and we will take a second day tomorrow.